All right, hey guys, we are doing 2.3 functions and their graphs today. Again, sorry that I'm not with you, but hopefully this will make some sense. So if you remember in chapter 1, we talked about 3 different symmetries: symmetric with respect to the y-axis, symmetric with respect to the x-axis, and symmetry with respect to the origin. And if you remember, to check y-axis, right, we had a second point on the graph. If xy was on my original graph, then another point would be negative xy. If it was symmetric with respect to the x-axis, the xy point would be there as well as x negative y. And then if it was symmetric with respect to the origin, you would also have negative x negative y. Now, of course, not all of these are going to be functions, right? Remember in 2.1 and 2.2, we talked about a function being a relation that passes the vertical line test. So if we go down to our notes, only 2 relations above can be functions, right? So out of the 3 that we listed above, y-axis, x-axis, and origin, only 2 of those can be functions, right? And if you think about it, if something is symmetric with respect to the x-axis, that means they have a point above and directly below the x-axis, and therefore there's no possible way that it can pass the vertical line test. So it turns out the x-axis one is never going to be a function. So that leaves us with 2 different symmetries with respect to the y-axis and with respect to the origin. So the first one I'm going to talk about is a graph that is symmetric with respect to the y-axis. And a graph that is symmetric with respect to the y-axis is called an even function. Right, an even function. And so if we think about what that means, it means the output for negative x is the same as the output for x. So if I have the point AB, and I know it's symmetric with respect to the y-axis, then I also have the point over here, which would be negative AB, right? Or I have the opposite outputs, right? A and negative A, but they give me opposite inputs, but they give me the same output, positive B. Right, so graphs that might look like this, right, parabolas. Some parabolas have symmetry with respect to the y-axis. Other things that we've seen in chapter 1, right? So an even function is symmetry with respect to the y-axis. So the other one is going to be an odd function. And an odd function is a function where every output for negative x is the opposite of the output for x. So what does that mean? Well, if you plug in A, you get out B. And if you plug in negative A, you get out negative B. Right? Graphically, this function is symmetric with respect to the origin. Odd origin. Both have O's. Right? So graphs that we've seen look like this might be x cubed graphs, or just lines, etc., etc. Right? So even is a function that has symmetry with respect to the y-axis. Odd is a function that has symmetry with respect to the x-axis. So how do we check this algebraically? Well, we've already essentially done this in section 1, but now we can use function notation since we are in the chapter of functions. And by definition, an even and an odd function are both functions. So remember, for an even function, if we plug in negative x, we should get out the same value as if we plugged in just regular x. So f of negative x is just equal to f of x for an even function. Right, and if you remember, for an odd function, we get out the opposite. Right? If you plug in A, you get out B. If I plug in negative A, I get out negative B. So if I take negative x and I plug it in, that's the same as negative f of x. So f of negative x is equal to negative f of x. And that means the function is odd. Excellent. So I'm going to do my checks just like I did in Unit 1, but the notation is slightly different. So now I'm going to have my function right here, f of x is equal to root 7 minus 2x squared, right? And now I'm going to plug in negative x and see if I get out one of these, either the original f of x or negative f of x. So I show my work, square root of 7 minus 2 parentheses negative x quantity squared. And just as before, if you have a negative x quantity squared, this just becomes a positive number. So this just becomes minus 2x squared. And lo and behold, this was just my original f of x. So I can say this is equal to f of x. And if you notice, I now had f of negative x is equal to f of x. And this means that this function is even. Wonderful. And you can plug this in on your handy dandy calculator, but the graph looks something like that. Clearly symmetric with respect to the y-axis, therefore it is verified as even. Next, right? Ooh, fancy. Next, I want to check to see what this one does. So again, I'm going to plug in negative x into my equation and see if I get out either f of x or negative f of x. So I plug it in. 2 times quantity negative x to the 5th minus 6 times quantity negative x cubed. And now, since these have odd exponents, the whole quantities are going to become negative. So negative x to the 5th is negative x 5th, but I can pull that out in front, negative 2x to the 5th. And now negative x cubed is going to be, negative x quantity cubed is going to become negative x cubed. Negative x cubed times negative 6 becomes positive 6x cubed. So now it's not quite my original function, so I'm going to go ahead and factor out a negative from both terms. And now this guy is now what my original function was. So another way of writing this is negative f of x. And lo and behold, I have just shown that f of negative x is equal to negative f of x, negative f of x, which implies that f of x must be odd or symmetric with respect to the origin. And if you check this with your handy dandy graphing calculator, it does something funky, but it does something like, ooh. Sorry. Something like that. Sorry, my graph's not the greatest. You can check with your handy dandy calculator, but you'll notice it is symmetric with respect to the origin. Okay, so if we look at example C on the top of the next page, we're given a new function, x plus 5 over 1 minus x. And we want to test to see if this function is even or odd. So we have some information going into the graph. Will it be symmetric with respect to the origin, the y-axis, or neither? So always I'm going to plug in negative x and see if I get out the original equation back, the opposite equation, or neither. So I plug in negative x and I get negative, oops, let's go black pen, negative x plus 5 all over 1 minus a negative x, which just becomes plus x. Now, this is definitely not the original function back, and there's no way that I can factor out a negative sign to make that top match what it's going to be, or the opposite function. So this is not even, nor is it odd, right? So f of x does not equal f of negative x. F of negative x does not equal negative f of x, therefore it's neither. And if you graph this on a handy-dandy calculator, which I highly recommend you do so now, make sure that when you plug it into your calculator you have parentheses around the numerator and denominator. But this graph will look something like this, I believe. And clearly not symmetric. Actually. Clearly not symmetric with the origin or the y-axis. So, exciting stuff. All right, looking at the next part of the graph, we've got to complete the graph given the function you know is odd. So odd, we know that f of x equals negative f of x, or from chapter 1, we can remember that if I plug in a point xy, the corresponding point is negative x, negative y. So if I have a point on my original graph that is 1, 1, then the corresponding point with symmetry would be negative 1, negative 1. And if I have the point 1, 2, 3, 4, 2, and 5, 1, 2, 3, 4, hopefully you can easily find that the other points would be negative 4, negative 2, as well as negative 5, negative 4. Right, and then you can draw in your lines. Sorry, I don't have a straight edge. And it should look symmetric with respect to that point there, right? Everything's kind of reflected through that point. Excellent. All right, moving on to C, right? If I want to do that same graph but make it even, now I know that from first chapter that a point xy is symmetric with respect to the y-axis if it also has the corresponding point negative xy. So if I have my original points, 1, 1, 4, 2, 5, 4, the corresponding points should be negative 1, 1, negative 4, 2, and negative 5, 4. And once again, I can draw in my straight lines. And now hopefully you can see that this graph has beautiful symmetry with respect to that y-axis there. My points all line up according to my rule, f of x equaling negative f of x. And we're going to pause there for today. You can work on the Math Excel. Just note that you might not be able to do everything since we didn't quite complete these notes with this video. See you on Tuesday.